Okay guys, this is over human populations. This is kind of looking at the different growth rates, different logistic growth rate models that we looked at in just typical environments, and now we're going to turn that and apply it to the human population. A lot of emphasis is going to be placed on looking at countries of different socioeconomic statuses, right? So different socioeconomic statuses. Socio-eco. So we're going to be looking at socio-eco statuses of different countries and looking at the effects of affluency and kind of taking a look at what that does to the carrying capacities for different countries and consumption rates of available materials and limiting resources. Okay, so at the beginning of this chapter, they kind of talk about China a little bit, and they discuss, is it ethical to have the child limit policy? Is it typical to have a child limit policy? So they have rights, right? Like we can ask, like, is that a violation of human rights, right? And one can argue that rights are given by a government, but another could argue that it's up to the world population, the world community to kind of decide whether or not certain countries are taking too many liberties at limiting their populations, right? So an argument can be had either way. But what's important to kind of note here is that even though they have kind of got their population under control, so they have their population under control right now, as we'll see later on, we look at population pyramids. You will notice that some of the things that you would expect from a lower population are not happening, right? So consumption of goods and production of CO2. So consumption and CO2 production is actually on the rise, right? Even though the population is decreasing in China. And we're going to have to look at that, and this really has something to do with affluency. You might think that countries that are really poor are going to pollute the environment more, but actually it really has a lot more to do with this idea of affluency. And the more affluent your country is, the higher the rate of consumption of products that require transportation, resources to produce. So just kind of keep those things in mind. All right. Scientists disagree on the Earth's carrying capacity. Some believe that we may not have a carrying capacity at all. This idea of human ingenuity, right? So human ingenuity. All right, so the idea of innovation really plays a role in kind of this idea of being able to increase the carrying capacity of a civilization, right? And so let's take a look at some factors here. The Black Plague happened about 400 years ago, and we see this gigantic spike in the population here. So this population growth rate is going out of control as of right here. This has to do with hygiene. Sorry about that. It has a lot to do with hygiene and medical technology, so medicine, technology. All right, so all these things are going to help with the population boom from about 400 years prior to that. Before that, we had very, very slow growth kind of going along this region right here, right? So you see a sharp spike. All right, scientists disagree on the Earth's carrying capacity. Some think that there is no carrying capacity limit. Others think it will cap out around 8 to 10 billion. So we'll see that. We'll see that by 2100. We'll see who was right. These two graphs right here have to do with the scientist the person who studied populations early on, Malthus. This is Malthus. He thought that the population is growing exponentially. You can see there's like an exponential growth here. But said that our food is growing only linearly, right? And eventually, when we hit this red zone here, we're going to hit kind of like our carrying capacity, and the population will have to decrease there. But what he didn't take into account was human innovation, right? The more innovation we have, the kind of the change in the slope of this food curve, or this limiting resource curve here. So this ingenuity kind of helps us, and we've done that many times through history. And so this kind of gives some scientists the idea that we're not sure if there actually is a limit to the amount that Earth can carry. Maybe we should just keep building upward somehow, right? Where we can keep building on top of each other. Even land eventually may not be a limiting resource, right? Maybe we can build structures that go upward, right? Certainly things like skyscrapers have kind of helped keep population densities really packed and keep land scarcity kind of at bay. All right, so the world's current population is about a little over 7 billion, 7.2 billion, and it's expected to increase. Factors that drive human population growth, these are very, very important here. Demography is the study of human populations and population trends. We are going to be practicing this quite a bit this chapter. Changes in population size. Obviously, the larger population you have with a certain given amount of resources, the quicker the rate of growth, right? Fertility, right? We're going to talk about socioeconomic statuses that lead to higher fertility rates, lower fertility rates, infant mortality rates, life expectancy. Every one of these you kind of want to attach to some sort of socioeconomic understanding of society. The age structure, right? If you have a lot of old people, you're obviously not going to have a high growth rate. And also down here, it's kind of hard to see, kind of cut off. We have like migration, immigration, right? Migration, immigration, all that good stuff. So all these things are things that will affect population. We'll get into the nitty-gritty of that right now. So immigration, the movement of people into a country. Emigration is out. So think of E as, we're having a hard time with that. Think of E as exit. Okay, so this is like the word exit. And this is like in, like come in, like welcome in, like the welcome in, right? All right. So net migration rate is the difference between the people coming in and coming out. And there's like some nice little graphics in your book that'll kind of tell you how to do the calculation on that. But here's a nice little convenient flow chart to kind of demonstrate that. So your inputs are going to be immigration and births. Births are usually a bigger arrow because they're contributing much more to the population in general. And then your outputs are going to decrease the population size. It's immigration and deaths, right? And we're going to get into different values for deaths and births. Immigration is usually taken over 1,000, like per 1,000 people. It's a rate per 1,000. So here we go. The crude birth rate, the CBR. You need to be very familiar with these initialisms here, these abbreviations. The number of births per 1,000 individuals per year, pretty easy, right? Crude death rate, the number of deaths per 1,000 individuals per year. And you're going to see that places that have lower crude birth rates and higher crude death rates are going to be very similar in socioeconomic statuses. So if you have high CBR and you have low CDR, you'll see kind of a positive correlation, or you'll see kind of a relation between these and these socioeconomic conditions. But there are some exceptions to that, right? There are some exceptions to that based on kind of like the availability of healthcare, right? You might have a place that has really low crude birth rates, like in the United States, and a higher than expected crude death rate. And can you think of a reason why that might be the case in the U.S. and A? Think about it, right? If we have a high life expectancy, high life expectancy, what's going to end up happening is even though you have low childbirth, so low infants, you also are going to have a lot of people dying off all at once. A lot of people die all at once because they just reach the end of their lives, right? Okay, now when you're calculating this, it is important to, let's get this stuff out the way. It's important that when you're looking at the growth rate of a nation, it's really, really simple. Right? You take the number of births that occur, add immigration to it because you're adding people to the country, and then you just subtract the crude death rate plus the immigration. And now, since these are over 1,000, there's a really convenient way of kind of doing this. So let's say that you had, so let's just make up a number real quick. Let's say you had 20 births per 1,000, and you have 2 immigrants per 1,000. And now you're going to subtract the crude death rate. Let's say we had, 8 deaths per 1,000. Right? We're just making stuff up. And we lose maybe nobody, right? Nobody's leaving this country. It's really nice, so it's gone. Right? What you can do is you can just kind of factor out this 1,000 across the board. Right? It's kind of nice. And then just divide by 10. Just divide the whole thing by 10. Not 100. Divide by 10. Okay, and it ends up working out the same way as if you were to divide by 1,000 and then at the end multiply by 100 to get your percentage. But what you're doing here is you end up coming up with a nice percent that's already done for you. So in this case, you'd end up with 22 minus 8 divided by 10, and you end up with, what is that? I can't do math right now. 14 over 10. So 1.4 growth rate, 1.4%, right? Now, if you were to do it the other way, just like add up 1,000, put like thousands under that, 20 over 1,000. First of all, this is really obnoxious, but at least it's in common terms, right? All right, so that's 22 over 1,000 minus 8 over 1,000. You end up with the same. You end up with the exact same thing, 14 over 1,000. Then you have to multiply by 100. It's the same as just dividing by 10 if you got rid of those numerators all at once. We'll practice this in class, so don't worry if you're not following this too much. I'm just trying to get through it kind of quickly. Your growth rate is compared. If you have higher than 30, it's considered to be pretty high, right? You're looking at probably low socioeconomic status country there. All right, now see if we can make this pen a little bit smaller. There we go. If it's below 18, it's considered kind of low. This is higher socioeconomic status. You're usually looking at places with increased or higher levels of education. Turns out if you're more educated, you usually tend to have less children per family. The global rate, you need to know this, about 20%. And you can see kind of the breakdown of countries that are rather industrialized and developed versus countries that are not, right? And these kind of average out to about 20 in the middle. Okay. You'll see that the countries that do well at certain statistics get really close to the number 0, right? They're a lot closer to 0, and the ones that are higher are like in the 50s, 60s. It's, some of it's pretty jarring. Total fertility rate, an estimate of the average number of children that each woman in a population will bear. And we are definitely going to investigate and study what contributes to fertility rate going up and down. And what you should definitely connect to every time you talk about fertility rate in women is the relative level of available education. When in doubt on an FRQ or just in general, if somebody asks you, educate women, give them a job, right? If you give women access to good jobs and education, you end up having better statistics across the board for fertility rate, infant mortality rate, life expectancy. Go figure, right? So if you just turns out if you take care of the other half of your population, things get better, right? So I mean, it's not like a sexist thing or anything like that. It's just you're taking care of half the people that think and work and contribute to society. Just kind of keep those things in mind, right? Even if you're not a super liberal, women's rights, just keep in mind, it's something that benefits everybody to make sure that everyone has equal access to everything. All right, so just keep that in mind. Replacement level fertility is different than the total fertility rate, and this is an important distinction to make here. So compare these. I might ask you to compare these in class. Total fertility rate required to offset the average numbers of deaths in the population. You do not factor in. So do not factor emigration. And why is that? You're not killing anybody that way. You're just moving them around, okay? So this is important. Do not factor in emigration. Okay? Cool. So here's our estimated population for the entire planet, right? So in the 1900s, we had less than 2 billion people. You see, we had like a very kind of intrinsic growth model for a little bit. Right now, it's getting into that logistical growth model, right? And we're not sure if it's going to peak up in the 10 billions or around 8.5 billion and then drop. And you know that every time you reach kind of like a limit, right? You're reaching kind of like an asymptotic relationship here. That this is going to kind of represent. This is going to represent like a carrying capacity, right? As you reach like this line here. Either here or here, you can see the carrying capacity. And this is going to be based on whether or not humans' ingenuity and technology and innovation can, push us even higher, or whether or not it won't, right? So this is kind of like the expected growth rate that we're going to look at in the next 50 to 100 years. All right, developed countries, in terms of fertility, they have high levels of industrialization and income. They're going to have, developing countries are considered places that make people that make $3 or less per day. Okay? And we're going to look at the effects on fertility there. Okay? All right, female education and the total fertility rate. So this is what we were talking about just a minute ago. Female literacy and school enrollment. School enrollment are correlated to the total fertility rate. The more women, more educated women have fewer children. Right? They have fewer children. Just keep this in mind. Not really a value or anything I'm attaching to that. That's just the way it tends to be, right? They're able to make better decisions. They're able to kind of think about their lives outside of just childbearing, and that has some positive effects on society in terms of advancement, and findings and affluence for the entire civilization as a whole. Now, it does have effects on growth rate of societies, and we're going to look at a couple of populations that do have really highly educated populations for men and women, and sometimes they do suffer in terms of population decline, right? And those are challenges that countries like Japan and Germany are facing, and we'll look at some of the challenges that they face. All right, so the replacement fertility rate is going to be the rate of replacement fertility rate is usually around 2.1, a little over 2. It's always going to be over 2. Just keep in mind, if there is a man and a female, male and female, and they both die, you need to replace them with at least 2 other people. Now, of course, there aren't 100% of children that make it to fertility age, so it has to be a little bit higher. Right? Now, countries that have high mortality rates, they don't have high life expectancies, are going to need things that are greater than 2.1, right? But in general, it's always going to be greater than 2. Right? Just keep that in mind. All right, now let's look at life expectancies. You notice, like, kind of these mid-regions here, through the equator, you kind of have a lot of problems, right? Even though you would expect there to be a lot of energy and resources, we look at historically that the energy and resources did not stay in these equatorial regions, right? The gains that these countries could have made for themselves were usually, as we know from colonialization, they were distributed this way, right? Higher up north at the higher latitudes, right? And if you look in this region right here, there is a lot of disease, a lot of poverty, really, really big limiting factor for population growth of human civilization is going to be disease. That's really important. And what disease can you think of in the past that might have been really big in Africa? In the past, not so much today, but back in the day we had things like malaria, right? Just things that really thrive in high temperatures, right? So high temperature, you know that from other chapters, higher temperature from global warming leads to more disease, right? But nowadays, malaria, of course, is a very, very big problem for some of these Central African countries. But we have a really big pandemic that started in the late 70s, 80s, that became globally known, of course, AIDS, HIV. And they estimate that, now this is really horrible, they estimate that of the 34 million people in the world that have HIV/AIDS, 22 million of those people come from the sub-Saharan Africa. That's really terrible. Sub-Saharan Africa, so big percentage of that, higher than 60% come from there. So that's why these areas kind of in the mid-region, the equatorial regions of the planet, kind of have the lowest life expectancies, right? Even though you would think they would have a lot of availability of resources, we know that the historical context of these regions have not been very equitable, right? Slide here. So look at the distribution of life expectancies. Kind of compare that. Okay, infant mortality rate, the number of deaths of children per 1,000 live births. You need to know this. When you are graphing things for FRQs in this chapter, do not go off of data points given. You need to go off of the scale of per 1,000, right? So you need to be counting by thousands. Just keep that in mind. Child mortality rate, the number of deaths of children under age 5 per 1,000 live births. So look here, kind of compare this guy over here. Do you see any do you see similarities, differences here? Okay. Age structure, so we're going to finish off 7A right now by looking at age structure. And the way we usually do this is by looking at the distribution of different aged individuals and percentages within a population, usually counted by fives, age increments of fives. Look at males and females. This is where we get into population pyramids. And we can learn a lot about what's happening in a country from year to year based on the distribution of their population, right? So you look at somewhere like this, you're looking at a lower economic status in this top left one. And what's happening here is there are a lot of younger people than there are older people, right? So this is experiencing an incredibly high rate of growth, right? Very, very high rate of growth. So the growth rate is very high here, right? And we're looking at low socioeconomic. So a lot of countries like in Africa, poorer countries, right? We look over here, let's go on to this more columnar shape over here. It's top right. Okay, this column shape is going to be population stability. And this is going to be kind of more like the United States, right? United States. And it's funny because the United States actually has a replacement fertility rate lower than 2.1, but we still have some stability in our population. Why do you think we might have a high enough replacement level for people, even if we don't have a fertility rate that would give us that? What do you think it is? All right, yeah, my wife April says immigration, and that is correct. We have an immigration rate that's kind of keeping our population up a little bit. And it's important to note, whatever side of the fence you are in immigration, that our net immigration rate is around 0. So people are leaving at about the same rate that they're coming in from. That doesn't mean they're leaving and coming from the same countries, right? We could have people leaving to India, right? They were here for whatever reason, and coming in from Mexico or coming in from Canada for whatever reason, maybe because it's so cold there and it's terrible. They have Justin Trudeau and parliamentary system and got their healthcare, right? Cool. So let's look on, again, I don't want to get too political or anything, but these are just things you can look up on your own. Okay, we have an inverted pyramid here, so that is, I want to make sure we go over all the shapes, sorry, this top left one, let's make sure we've covered the fact that this is a pyramid. Okay, and pyramid you want to associate with these guys right here. Okay, now let's look down here. This is an inverted pyramid. Inverted pyramid. Inverted just means flipped, upside down. An inverted pyramid, you have a much higher proportion of your population in the older ages than younger, and so you are going to see a population decline in the future. Population decline. Population's going to go down. Right? And examples of that are going to be industrialized countries like Germany, some parts of Western Europe, other parts of Western Europe. And you're going to see that places, Japan is like this. Japan, oh man, Japan. You're going to see places that are very anti-immigrant. Very anti-immigrant. Or immigration, I should say. Not necessarily because of just xenophobia, but in some cases, xenophobia. And places that are anti-immigration are going to have flipped pyramid curves over a long period of time. And they're not doing the replacement of the people that are dying off in old age, right? So in Japan specifically, you have something called the graying. Gray, the color gray, the graying of society is what it's called. Right? A lot of women are getting jobs, and of course women getting jobs, becoming career women, getting educated, having higher levels of education, what's going to happen to the birth rate? We know this, right? We know that the birth rate's going to go down. The replacement fertility is going to go down, and at the same time, they are very averse to people that are non-ethnic Japanese. And even though ironically, a lot of the ethnic Japanese are likely descendants of people from the mainland of Eastern Asia. But at any rate, they have some hang-ups about people from India and Bangladesh and things like that, and so they don't like people coming into their country, and they're starting to see ramifications on the job force, the labor force. And in the next 50 years, it's going to be very interesting to see, are they going to use Gundams and Ninja Turtles to do all their work? I don't know. We'll find out. Okay, and over here we have a very unique population pyramid. It's not It's not really a pyramid, it's not a column, but you see something is happening, right? Back in the day, you see the older people here. So the older people represent times in the past, right? So this is going to be the past. So back in the past, we had rapid population growth in this country. So they had to do something here to kind of stave off, stabilize that stuff right here. So these are usually, since we're looking at China, we know that around this time we had population control, we had like birth laws, birth number laws, right? Child number law. The amount of children you had was determined by the government, right? And that's what we were saying at the onset of this lecture. We can debate whether or not that's a good or bad thing. But we're starting to see now that this is the very beginnings right here. It's the very beginnings of population decline. Right? And whether or not that's had positive effects on the environment and the economics of China is really up in the air, because as we talked about, the higher your affluence gets, the higher your rate of consumption. Higher the affluence, the higher the consumption. So that doesn't mean that you have more resources just because you have a smaller population, right? All right. So migration can cause countries to grow as well. So the U.S., we have 3.3 per 1,000. Fiji, -8 per 1,000. So they're losing people. But Fiji is still expected to have an increasing growth rate because their fertility rate, right, their total fertility rate is still really high. It's enough to replace the people that are leaving. Right? Which country is undergoing rapid growth rates? We know this, right? So we look for the pyramid, regular pyramid, bam, right there. Cool. Thank you. All right, and that is it for this lecture.